In this video, we're going to introduce arithmetic progressions. Now, these are just sequences where to get from one term to the next, you just add or subtract the same amount each time. So, a simple first example, 4, 7, 10, 13, 16, so on. This is an arithmetic sequence, arithmetic progression, because each time we're just adding 3. A second example, 11, 6, 1, minus 4, and so on. Also an arithmetic sequence because we're now subtracting 5 each time. A fixed amount we subtract each time. Okay. When we're working with arithmetic progressions, there's a little bit of notation we need to be aware of. The letter A is used to denote the first term in our sequence, and D is used for the common difference, the thing we add or subtract each time. So going back to our first example, well, A, the first term is just 4, and D, the common difference is 3. Our second example, A, the first term is 11, and D, the common difference is minus 5. Okay, and the reason why we care about this A and D notation is because there's a few formulae that we end up using with questions involving arithmetic progressions. So let's just concentrate on the first sequence for now. And the first formula that's useful to know is what's called the nth term formula. So nth term, and this is often called UN. The formula is A plus n minus 1 times D. And what that means is if we substitute A, N, and D into this formula, we can work out any term in the sequence without having to write down all of the sequence before it. So if we wanted the fifth term of the sequence, well, that's U5. All we're going to do is substitute 5 into this formula. A plus 5 minus 1D. We're going to put n equals 5 into our formula. We know what A and D are. A is 4 and D is 3. So what we get is 4 plus 5 minus 1 is just 4, and D is 3. This turns into 4 plus 4 times 3, which is 16. And we already knew that the fifth term of the sequence was 16, but this is another way to show it. The reason why this formula is useful is if we were asked for, let's say, the 50th term, it would be really long and annoying to have to write down the whole sequence up until then. So using the formula is a much quicker way to work out the 50th term. U50 is just A plus 50 minus 1 D. Well, that's just A plus 49D. Well, A is 4 and D is 3, so this is just 4 plus 49 times 3, which is 151. Okay. So that's our UN, our nth term formula. There's another formula that's useful to know, which is called the sum of the first n terms. So let's look at that formula. So we use Sn to mean the sum of the first n terms, and the formula is n over 2, 2a plus n minus 1d. This is sum of first n terms. Okay, so what does that mean? Well, S5, for example, is the sum of the first 5 terms. So that's the first term plus the second term plus the third term plus the fourth term plus the fifth term. In this example, it's 4 plus 7 plus 10 plus 13 plus 16, which is 11 plus 21 and 34. It's 50. So again, we can work this one out quite easily just by writing the sequence down. But the formula will be useful if we're looking for, if we're working out, let's say, the sum of the first 50 terms. Anyway, let's just check that the formula works. Let's use our formula for S5. Well, the formula is n over 2, so 5 over 2, 2a, so that's 2 times 4, plus n minus 1, that's 5 minus 1, lots of d. Okay, let's just simplify the brackets. We get 8 plus 4 minus 1 is 4 times 3 is 12. We get 5 over 2 times 20, which is indeed 50. So our formula worked out fine. Now, as I said, let's say our question was not work out S5, but work out S20, the sum of the first 20 terms. Then the formula is going to be a lot quicker than actually writing all the 20 terms. We're just going to do n over 2, 20 over 2, 2a, so that's 2 times 4, plus n minus 1, so n is 20, n minus 1 is 19, and d is 3. So now we get 20 over 2 is 10, 2 times 4 is 8, 19 times 3 is 57. So we get 10 times 65, which is 650. That's the sum of the first 20 terms of the sequence.